Hi, my dear students. Welcome to India's biggest online platform, Manifold Institute GATE classes. Today, we are going to discuss a very interesting topic, hydrostatic forces on surfaces. In this session, we can discuss some problems based on hydrostatic forces on surfaces. Let's start the session. See here, a cylindrical gate AB as shown in the figure. The magnitude of force F per unit width of the gate to keep it closed is dash kilonewton. Okay, so here a force F is acting at point B. Okay, so this force is pushing the gate in order to close the gate. What is the magnitude of force we need to maintain to close the gate? Clear na? So that part we need to determine. For that, we need to draw free body diagram for this particular case. So to draw free body diagram, you should have full command on the horizontal force acting on the gate and vertical force acting on the gate, and what are the different locations, what are the locations of corresponding forces as we solved in the last problem. Okay, just to see here, we need to do horizontal projection. Here you projected horizontally. Okay, so once you project a curved surface horizontally, you will be getting a rectangular cross section. Here, what is the width of the gate? Per unit width means width equal to 1 meter you can take, no issue. So width of the gate is 1 meter. Okay, so radius 5 meter. Now we need to determine force acting on the curved surface in x direction. Here, what is FH? Tell me. Rho G into AH bar. Okay, so what is H bar? Tell me. H bar, tell me. Here, 3 meter plus total 5 meter na radius. R by 2, right? R by 2 total radius. So here how much you will be getting? 3 meter plus 2.5 meter, 5.5 meter, that is H bar, and area A equivalents to, tell me, 5 meter square. So finally, what is the magnitude of FH? See here, 10 cube kg per meter cube into 9.81 meter per second square into area, so 5 meter square. H bar is nothing but 3 plus 2.5, 5.5 meter. 5.5 meter is equivalent to dash kilonewton. Calculate and tell me. FH equivalents to dash kilonewton. 9.81 into 5 into 5.5. So 269.775. 269.775 kilonewton. So coming to the H star, that is the location. What is H star here? How to determine H star? 2 times H by 3. No. Sorry. Here, how to determine H star? Tell me. Yeah. Now, how to determine the location of center of pressure? Center of pressure is at a distance H bar from the free surface. Okay. How to determine H star? One minute. క్లోజ్ చేయొద్దు, ఒక్క ప్రాబ్లం ఉంది. ఎన్ని గంటలు ఎన్ని సేపు వచ్చింది? ఏం కాలేదు, కట్ చేస్తాను. Now we need to determine the location of center of pressure. Center of pressure P is at a distance h star from the free surface. Now, how to determine the location of center of pressure? H star equals to h bar plus IgG by AH bar. AH bar. What is H bar here? H bar here. So 5.5 meter. So now tell me, it is 5.5 meter plus IgG is nothing but 1 into 5 cube by 12. 5 cube by 12. ठीक है, IgG by 5 into 1, 5 meter square into 5.5 meter. Now tell me, what is the value of H star in terms of meter? 5 cube by 12, 5 cube by 12 by 5 by 5.5, okay, plus 5.5. So you will be getting 5.87. Here 5.878 meter. 5.878 meter. H star. Just calculate once. 5 cube by 12 by 5 divided by 5.5 plus 5.5. So 5.87 you will be getting. H star equals to 5.878 meter. 5.878 meter. Clear na? So H star equal to 5.878 meter. Now we can focus on the vertical force, hydrostatic pressure force acting on the curved surface in y direction. See here how to determine Fy here. Here fluid present below the curved surface. Below the curved surface. That means curved surface is experienced by the buoyancy force. How to determine Fv in this case? Weight of the fluid displaced. Weight of the fluid. Weight of the fluid displaced. Clear na? How to determine weight of the fluid displaced? Density of the fluid into volume of the fluid displaced into G. So to determine volume of the fluid, we need to calculate area of cross section. Okay, it's a buoyancy force always act vertically upward direction. That means we need to project the area from curved surface to the free surface. So that is A star. From the curved surface to the free surface. Okay? So from that you will be getting volume of the fluid displaced. Density of the fluid into A star into width of the gate into G. That is Fv. Now tell me how to determine Fv. Vertical force Fv equals to density of the fluid. Clear na? Into A star, width of the gate is 1 meter into G. What is A star? Tell me how to determine A star. Total area of the rectangle. So that is, this will be R into 3 plus R. That is total area. R into 3 plus R. 3 plus R. That is area of the rectangle minus area of the quadrant circle minus pi R square by 4. Pi R square by 4. Clear na? Now this is A star. Width of the gate is 1 meter. Finally, what is Fv? What is Fv? Equivalence to density into R 3 plus R minus pi times R square by 4 width of the gate into G. So now substitute all the values here. 10 cube kg per meter cube into what is R? Tell me. 5 meter. 5 meter. Here 5 meter into 8 meter. 5 times 5 square by 4 into 1 meter into 9.81 meter per second square. Now tell me, what is the magnitude of Fe here? What is the magnitude of Fe in terms of kilonewton? Tell me. In terms of kilonewton, 5 times 25 by 4, okay, pi r square by 4 plus 40, clear na, into 9.81, clear. So finally 199.781. So that is the, in terms of kilonewton, 199.781 kilonewton. That is the vertical force acting on the curved surface. Okay, so now we need to calculate the x bar. X bar. Okay, so what is the location of vertical force acting on the curved surface? See here, taking moment of area about hinge point A. So here it is O. Okay, so how to calculate? Same procedure we need to follow. First consider total area. Total area means total rectangle. Okay, so it consists of two portions. One area will be A star. Okay, total this will be A star, this will be A. Okay, first consider total rectangle. Total rectangle, moment of area of the rectangle about hinge point. So that is A star plus A, moment of total area. Centroid will be somewhere here. Okay, so that is what distance between, perpendicular distance from the centroid to hinge point. Tell me, hinge point, tell me, that will be r by 2 into r by 2, moment of area of the rectangle about hinge point A. That is equal to, first focus on the area A into, what is this particular distance? Centroid somewhere C1. C1 we can say this will be 4r by 3 pi. 4r by 3 pi. Now tell me, 4 times r by 3 pi plus A star. Total remaining area A star. What is the centroid of that? Somewhere here, centroid C2. That is the distance x bar into x bar. Now we need to calculate x bar. That is the point of location of the vertical force acting on the curved surface. Now tell me, A plus A star is nothing but how much? Tell me, r. This will be r into 3 plus r. R into 3 plus r into r by 2. R by 2. So what is A? A is area of the quadrant circle. That is pi times r square by 4 into 4 times r by 3 pi. 4 times r by 3 pi. A star into x bar. Here 4 pi gets cancelled out. R cube by 3 will be getting. Now finally, what is x bar? X bar, or else A star into x bar. Here what you will get? Tell me. So this will be r plus 3. R plus 3 into r square by 2. R plus 3 into r square by 2 minus here 4 pi gets cancelled out, r cube by 3. R cube by 3 by A star. A star is how much? What is A star? Just now we already discussed that part. A star is nothing but r into 3 plus r. That is area of the rectangle. Okay, so minus pi times r square by 4. So that part we need to discuss here. So here r plus 3 into r minus pi times r square by 4. So once you substitute r here, you will be getting in terms of meter. What is x bar? What is x bar in terms of meter? Here r equals to 5 meter. Just substitute and tell me. Substitute and tell me. 8, 5 plus 3, 8 into r square 25 by 2. Here it will be 100 minus 5 cube by 3, 5 cube by 3, 5 cube by 3, 58.33. Numerator na 58 point x bar equals to 58.33 meter by denominator. How much you are getting? 8 into 5 minus or else pi 25 by 4. Okay, so here 5 plus 3, 8, 8 5 is 40. So here you will be getting 20.365. Here meter cube you will be getting, here meter square. So finally, how much you are getting in terms of meter? 58.33. So 2.864 x bar equals to dash meter. How much you are getting? Tell me. 2.864. 864 meter. 2.864 meter. So x bar equals to 2.864 meter. Now we can draw free body diagram for given gate. Okay, see here. So FH is acting at center of pressure, FE is acting at a distance x bar from the hinge. Okay, na? So F is the, we need to calculate the magnitude of force F to keep it closed. Okay, na? To keep the gate closed. Clear? Now apply moment about hinge. Apply moment about hinge is equal to 0. Now just see the thing. Moment of FH about point A is acting clockwise direction. Moment of vertical force acting about hinge point is clockwise direction. Moment of force F is acting about point A is anti-clockwise direction. Okay, sum of the anti-clockwise couples equal to sum of the clockwise couples. Now see here, F times F into radius. Moment of a force F about point A is anti-clockwise direction. That is equal to F into R, equal to FH. FH into moment of FH about point A. That is equal to, tell me, how much you are getting? H star minus 3. Correct na? H star minus 3 meter. Minus 3 meter. That is the, and that is clockwise direction. So this distance we need to take. Next, moment of FE about point A. That is also clockwise direction. FV into x bar. Here just now we determined FH equal to dash kilonewton. FH equal to dash kilonewton. H star equal to dash meter. FV equal to dash kilonewton. X bar equals to dash meter. Now tell me, what are the things we determined till now? What is FH? What is FH? 269.775. 269.775. 269.775 kilonewton. What about x bar? 2.864. 2.864. FV equals to 199.781. 199 point, what is this? 199.781, 199.781. Now coming to the H star 5.878, 5.878, 5.878 meter. Now substitute all the values in this beautiful expression. So F into how much you are getting? 5 meter, R is 5 meter, equivalents to FH is nothing but 269.775 kilonewton into this is how much? 5.878 meter minus 3 meter plus Fe is nothing but 199.781 kilonewton into 2.864 meter. Finally, what is the magnitude of F we need to maintain to keep the gate closed? See here, just calculate and tell me the answer. Here, how much you are getting? 5.878 minus 3 into 269.775 plus how much you are getting? 199.781 into 2.864 by 5 meter. So finally, we'll be getting 269.717. Finally, you will be getting 269.717 kilonewton. That is the answer. See here, 269.717. So F equals to 269.717 kilonewton. Yeah. In this session, we discussed how to determine the magnitude of hydrostatic pressure force on surfaces. In the next session, we can work on the problems on buoyancy and flotation. Thank you. We can meet in the next class. Thank you.